This is 7b97z49d, and it's line 22. Whittaker Shannon, Lithium, Higgs crystals, super lattice formula, 5G Wow Seti. There's the alien radio signal. And it's about algorithms, laser beams, Higgs signals, Whittaker Shannon pulses for a UFO space communications device found in line 22 WOW data. I'm assuming, and it says the formula. And data creates formula, which I forgot to put there. So then the previous video on September 14th, 2013 was line 22, 7b97z49c, Dirac, comb, Whittaker, Shannon, Nyquist, folding frequency formula, 5G Wow Seti, and I'm filming this October 6th. So the keyword Whittaker Shannon interpolation formula quote from wiki. Stationary random processes. If xn is an infinite sequence of samples of a sample function of a wide-sense stationary process, then is not a member of any, I think it's, or LP space. Probability 1, that is the infinite sum of samples raised to a power p, does not have a finite expected value. Nevertheless, the interpolation formula converges with probability 1. Convergence can readily be shown by computing the variances of truncated terms of the summation and showing that the variance can be made arbitrarily small by choosing a sufficient number of terms. If the process mean is non-zero, then pairs of terms need to be considered to also show that the expected value of the truncated terms converges to 0. Since a random process does not have a Fourier transform, the condition under which the sum converges to the original function must also be different. A stationary random process does have an autocorrelation function, and hence a spectral density according to the Wiener-Kincham theorem. Suitable condition for convergence to a sample function from the process is that the spectral density of the process be 0 at all frequencies equal to and above half the sample rate. See also aliasing, anti-aliasing filter, spatial, anti-aliasing Fourier transform, rectangular function, sampling, signal processing, signal electronics, Sinc function, and Sinc filter. Anti-aliasing filters are commonly used at the input of digital signal process systems. For example, in sound digitization systems, similar filters are used as reconstruction filters at the output of such systems, for example, in music players. In the latter case, the filters to prevent aliasing and the conversion of samples back to a continuous signal, where again perfect stop band rejection would be required to guarantee zero aliasing. The theoretically impossibility of realizing perfect filters is not much of an impediment in practice, though practical considerations do lead to system design choices such as oversampling to make it easier to realize good enough anti-aliasing filters. September 13, my thoughts. Diffraction of laser beam sound signals comes to mind here. Errol, UFO, Roswell, Mexico, 1947. Quote from wiki. The mathematics of sampling in two spatial dimensions is similar to the mathematics of time domain sampling, but the filter implementation technologies are different. The typical implementation in digital cameras is two layers of bifringent materials such as lithium niobate, which spreads each optical point into a cluster of 4 points. September 13, my thoughts. When I see the quote from wiki, optical point into a cluster of 4 points, I think of this. Formula idea. Fluorine atoms spinning, proton energies, laser beams, diffraction, obsidian mirrors, fluoroscopy device, water, quantum dots, vapor, inventions found in line 22 WOW data formulas. Optical point plus rubidium, cold atoms spin at the nodes, microwires, quantum wires, fiber optic wires, L. Shelby twist. Actually, hollow core. I'll change that to. We found out about the hollow core fiber optic wires, which would be DARPA and Cougar technology. Add some L. Shelby twist to those wires and put them around the nodes. Then you have your Higgs boson signals amplified, a cluster of 4 points, which would be the 4 monopole magnets, and add the 6 quadrupole magnets, creating magnetic field, and electron holes plus Higgs electric field. A Higgs electric field, we're going to create that. And we'll add some voltage, some currents, crystals between. You want piezoelectric crystals. Piezoelectric. We're going to use piezoelectric crystals between two superlattice structures. We have electron ribbon pencil laser beams. And then you have diffraction with mirrors. And then within the two layers of bifringent material, which would be graphite films, crystal, and superlattice. Oh, we got crystal wafers. Hold on, crystal wafers, plus the superlattice walls, plus diamond dust wafers. And we're adding lithium niobate, so I'm going to Google it to see what we can use with it. There's a lithium, and it's a quote and diagrams in wiki. Molecular formulas: LiNBO3, the mass, appearance, density, melting point, solubility in water, band gap, refractive index, structure, crystal structures, trigonal, space group, and point group. Okay. Lithium niobate, LiNBO3, is a compound of niobium, lithium, and oxygen. Its single crystals are important material for optical waveguides, mobile phones, piezoelectric sensors, optical modulators, and various other linear and nonlinear optical applications. September 14th, the formula continues. Optical waveguides, mobile devices, piezoelectric sensors, crystals, mapping wave patterns in Higgs boson signals going through the electron holes in the superlattice walls of the crystalline structures. Optical modulators add vibrations, readings, brain of the UFO core engine, plus computer systems adding visible lights, plus linear, plus nonlinear optical applications, future computer processing speeds and systems, which we will learn from the atomic dance of quantum particles from the WOW data formulas found in lines 1 to 27. We did some atomic dance already. It's supposed to be quantum atomic dance of quantum particles, quantum mechanic particles from the WOW data formulas found in lines 1 to 27. The keyword atomic quantum dance plus superfluid velocity atoms formulas are going to continue in the next video. Thanks for watching.